we go.
All right.
And people are already. Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance. We're getting started just a couple of minutes late here. My fault. But we're all here, and I've got Terry Mann, Vice President of the Astronomical League, and she's in an incredible library with a beautiful view of the cosmos.
I wish I was.
I've got the cosmos right here, so.
Well, there we go.
Anyhow. It's great to have everyone here for this weekend. A great way to kick off a Friday. And I'm going to turn it all over to you, Terry. Thanks.
All right. Thank you, Scott. Well, welcome, everybody. It's been a pretty nice day so far. At least we aren't flooded with rain. Since we are starting just a couple of minutes late, I'm going to go straight to David Levy. And how about if you start our evening off for us, David?
Well, thank you so much, Scotty and Terry and everyone else who's here today. Sorry it was, Scotty said it was his fault, but I would like to say it was my fault that we started late. But anyway, here we go. I'm going to give you a poem today that I haven't read in some time. It is from Amateur Telescope Making at the beginning of book 2, and it's a wonderful poem written by C.A. Olson, and it's called A Piece of Glass. He labored late into the night. At early morn his task resumed, to fashion from a disk of glass into a subtle curve, not deep, but measured only by the shades of light from a simple pinhole made in foil, revealing to his practiced eye imperfections infinitesimal, until at last his skill produced a curve so true the mind of man could not discern the wavering of a breath. Just a piece of glass, 'twas said, but in that simple disk the heavenly host of suns and stars, yea, universes, revealed their glory in the sky for us to ponder and adore. It's just a few words to talk about grinding glass to make a telescope mirror. But when you look through the telescope, magic takes place. I have outside 4 telescopes that I use every day and every night. And as soon as our League Live is finished today, I will be going out and using them. And I'm still searching for comets. I don't expect to find any more. But it is the search to me that is the magic part. Anyway, back to you, Terry, and thank you for letting me do this.
Well, thank you for joining us. And I don't think I could have said it better. I think a few of us at least have tried to grind mirrors or have made their own mirror. I made an attempt at it one time. And boy, I walked around that barrel just doing all the grinding, and I never did get it finished. I was trying to do a 6-inch f4 and didn't quite get that done, but that was an experience. And, I think the fact I did that, I can understand that poem even better. But you said that magically, David. Thank you very much.
Thank you. I also started to grind a 6-inch diameter mirror and gave up after one day. but I use a telescope with a 6-inch f4 mirror virtually every night. It
There
is
you go.
57 years old and its name is Minerva.
Oh, that sounds great. Well, thank you again, and we will see you next month, hopefully.
We certainly shall, yes.
Okay, thanks.
Thanks,
All
Terry.
right. Next up, how about President Chuck Allen? I think he's going to talk to us about some of the observing clubs in the league or a little update on the league, a little bit of everything. So, Chuck, welcome. Thanks for being here.
Thanks, Terry. I appreciate it. And I hope the storm outside will let me continue for a few minutes.
Yeah.
Let me share screen and get started because we have something special that's happened. Hold on just one second. Here. Okay, this is not where I want to be. All right, hold on. I'm going to rip back real fast here. Okay, this is where I want to start. There was an announcement made just a couple of days ago about another discovery from the James Webb Space Telescope, a new record holder, the new furthest object ever detected. And it's unfortunately on Father's Day coming up, Mom Z14. And it's in sextants. It was a little more than 2.5 billion light years away when the light left there and headed toward us. In an expanding universe, of course, that light took 13.53 billion years to reach us. And by the time it got here and gave us this picture, it had moved out to a distance of 34 billion light years. That's where it is today, and of course, a far advanced form that we will never see. But this is the new record holder, just announced on archive back in May 23rd of this year. I do want to talk about the observe programs because they're very significant for us. Just about 5 years ago, I did a program about them, and we had 18,000 members at that time. And today it's 25,000 members, just 5 years later. And a lot of that has to do with the observe programs that people are so involved with. These programs, of course, have been around for a very long period of time. And we have over 80 of them. Now, some of the regiments have as many as 2,400 objects to observe, some of them 50, 60, or 100, and some of them involve some degree of analysis as well. So you learn a lot during the course of the program. The first program that we had was the Messier program, and that resulted in the first certificate being issued on January 19th, 1967. This is not that certificate, just a sample of it. But it went to Catherine Delaney up in Pittsburgh. And since then, we've issued 16,140 certificates to over 5,600 different people around the world. Some of the programs that we have involve open clusters, for example. Observe 100 of them, attempt to estimate their Trumpler classification, and you get the pin and certificate. Globular clusters, 100 of those. The Sawyer-Shapley concentration analysis is required. We have alternate constellation programs. Very interesting to examine the constellations that other cultures have recognized over the years, like Buffo the toad in the lower left, and the forbidden fish from Aboriginal culture. They saw the belt stars of Orion as three boys in a canoe, the ends of which were Rigel and Betelgeuse. And they had captured the forbidden fish, which was the Orion Nebula. And because they violated tribal rules, they were cast into the sky. We have 3 lunar programs, the third of which, the Lunar Evolution Program, asks you to observe 57 objects on the moon and estimate their geological epoch. Should be called seleniological epoch, but for some reason it's geological in the program. We have a Dark Sky Advocate program, which is extremely helpful. Oops, sorry, did I cut out the program?
Nope.
No.
Still there.
Okay, hang on. Okay, there we go. This is a program that asks you to examine methods of combating types of lighting that affect all of us, examining lighting laws, and observing the differences that are made by observing in polluted areas as opposed to non-polluted areas. such as Bryce Canyon, where we'll be for our convention in a couple weeks. Convention with over 440 people registered. And if you're one of those, I greatly appreciate your giving us such a fantastic convention coming up. It'll be wonderful. We'll be observing at 9,000 feet. We have stellar evolution and carbon star programs. We have, of course, solar system programs that involve a very wide variety of activities, such as estimating sunset and sunrise azimuth, eclipses, locating outer planets, examining Jovian moon eclipses and transits and shadow transits and so forth. 2 different solar programs. This H alpha program involves classifying different kinds of prominences and observing features such as spicules and filaments on the surface of the sun. We have a bright nebula program and a dark nebula program. We have multiple double star programs. We have multiple now binocular programs as well, 10 of them. We have comet programs. We have, of course, a host of programs that involve galaxies, as you can see here, and some of them are moderately difficult and require fairly good aperture, others not so much. We have planetary nebulae program, and we have meteor programs with reporting to ALPO, and of course, variable star programs as well, which involves reporting to the AAVSO, and might get you started as a variable star observer as well. What these programs do is drive you to observe things that you didn't or wouldn't ordinarily observe. Too many people go and observe the same old every time they go out because they're really not directed toward anything new. But these programs do that. They kind of force you to look at something you've never looked at before. And it's fascinating when you get started. It becomes quite addictive. You end up observing really faint stuff like these 2 galaxies on either side of this field right here. As I observed them and sketched them, I noticed a little tiny faint blob that seemed to be moving along with them in between. It turned out that it was listed at magnitude 16.0. And sure enough, when I went home, there was a galaxy there. These are some of the pins that are awarded with completion of these programs, and they're beautiful. They make nice displays, or you might want to wear them. All of our program completions are reported in Reflector, each issue. We have also Master Observer certifications. No other organization does that. The Master Observer Award goes to people who complete 10 programs, including 5 required programs. And then we have a series of advances beyond that, all the way to Master Platinum. We give out these Master Observer plaques if you go to the convention to pick it up. So you've got to attend a convention and have completed the Master Observer requirements. And it involves a lot of work. A lot of record keeping, but when you get hooked on this stuff, you'll find that you'll be out even in 2-degree weather like I was on this particular night. I had already torn down most of the stuff, but it was quite cold that night, but you have to learn to dress for that because you've got to use those long winter nights. And you'll make a lot of new friends doing this as well, as you can see here. So please give them a shot. I guarantee you, if you complete 1 or 2 of these programs, you will probably continue with them. Thank you very much, Terry.
Thank you, Chuck. And it's kind of like I always call you, you're kind of the go-to system. You know where everything in the sky is at, even down to the faint stuff. What level Master Observer are you?
Well, I'm gold, but only because I'm not interested. Gold requires, I think, 20 programs to be completed.
Wow.
I'm at 44, but I'm not interested in
Wow.
radio astronomy that much, so I'm not interested in platinum.
Wow, that's amazing though, Chuck. How many years did it take to do that? I mean, I know you were off and on sometimes, but
I went from completing 4 to completing 43 since 2018.
Oh, wow.
Yeah. But he is very dedicated. Like you said, I've heard him say, I'm out in 2-degree weather. I'm waiting for the clouds to clear, yeah. And not to mention the pets he's probably brought home.
I brought home a black widow once.
Oh, gosh.
Yeah.
Yeah, that doesn't sound too good. Well, thank you, Chuck. Appreciate it.
Yeah,
how about next, let's talk to John Goss. Now, John is a past president, and he's also media officer right now. So, John, what's on your mind tonight?
Well, a number of things. I want to start out by telling you my talk is going to be about ocean tides. Before I do that, I'd like to preface the whole thing by saying I just realized that today is D-Day, and the whole a great part of the success of D-Day was the tides, and the tides are tied to the phase of the moon, and it was just about full moon when D-Day occurred, and they chose that for other reasons as in addition to the tides. But anyway, so I'd like to get started on what I have prepared. There we go. June 6th, beginning of June. Well, for a big part of the country, we're now at the beginning of beach season. People like going to the beach. But like it or not, when you're at the beach, you are affected by specific celestial forces, which is what we're going to talk about in relation with the tides. I grew up in a little town called Port Townsend, Washington, which is on the entrance to Puget Sound. And in doing so, or living there, I was always acutely aware of the tides, high tide, low tide, or so on. I might not have been able to tell you when they were going to happen, but I certainly saw them every day, saw the rise and fall of the water. This is the downtown view. The town is to the right, but you can see that this is about low tide, and it rises maybe 6, 7, 8, 9 feet, something like that every day, and then sinks back down. This is taken by a friend of mine, Peter Frary, who's, I think, a really great photographer, and he knows Port Townsend really well, so he let me use this image. Here's an example. I'll get into some of this means. This is an example of the tide height throughout the month. This is in Port Townsend for June of this year. And as you can see, up and down, up and down, up and down, rather cyclic nature, but there are some dips and high points, low points. I spelled out where the apogee of the moon is and the perigee and where the new moon is and the full moon. And I'll get into why all that really is significant. When I was researching this, a lot that is on the web that has been said about tides is either wrong, or it's inconsistent, incomplete, or it's really technical. I don't think you want to start talking about the X, Y, and Z vectors and the cosine and sine components of them, but some of this stuff's pretty complex. But really, any explanation of the tides has to account for a number of observed occurrences that you're going to see in a month. There are 2 high tides, 2 low tides on most days, not all days, but almost all. There are 2 high tides that are of unequal height on, again, most days. The high tides vary throughout the month. The low tides vary too. Some high tides are really high. Some high tides are really, really high. And you all notice that the high tide or low tide arrives about 50 minutes later each day. Not exactly 50, but about 50. So any explanation for why this is going on has to take these into account. I think if you asked most people on what is happening with tides, they'll say, oh, it has to do with the gravitational pull of the moon or the sun. Yes, but there's a third force at play, which is equally as important, more important, that people just don't realize. And we'll jump into that in just a moment. So these are the 3, which of course I just said, but we have the third force, which is the Earth's gravitational pull, but it's not at all in the way that you probably think. We'll explain that. But first of all, I want to take care of some of the forces which you're thinking of. Oh, what can affect the tides? Well, the Earth's gravity, but not really, because the Earth's gravity doesn't change, at least from one spot or in the same spot each month all the time. It's unchanging. And the rate of Earth's rotation, of course, is 1 day, and that doesn't change. So these 2 forces we can just eliminate and not even consider for the rest of our discussion. Force number 1, the moon's differential gravitational pull. That's a biggie, and it's kind of what a lot of people would think. Have a little diagram here showing the moon off to the right, Earth to the left. Point A. Point A sees a higher lunar gravitational force because it's a little bit closer to the moon. Point B, a little bit less because it's a little bit farther from the moon. And we're not really going to talk about C. That's up near the poles. And the polar regions really don't see much tides. We're going to skip the second force that has to do with the sun and go on to the third one. We'll come back to the sun in just a moment, but the third one, kind of a mysterious force. All it has to do, it takes into account the center of gravity of the Earth-Moon system called the barycenter. And this is how it does it. Earth actually orbits a point that is the center of gravity between the Earth and the moon, orbits it every month, and the moon does too, but we don't care about the moon, about that at the moment. But the Earth orbits it. That happens to be, the center of gravity happens to be about 3,000 miles from the Earth's center, always pointed towards the moon. So that puts it about 1,000 miles below the Earth's surface at its closest to the surface. Otherwise, it's like 7,000 miles away. And those 2 points orbit the barycenter, which means that point A is closest to it, so it orbits the slowest, and it has the smallest centripetal force because of that. Point B, on the other hand, orbits the farthest, and it happens to have the greatest centripetal force, because it's both these points take 1 month to go around this point of the barycenter. Very important to realize that. So you add these two things together, what you're going to have are high tides on both the side towards the moon and the side of the Earth away from the moon. And they add together, so sometimes these tides can be quite substantial. Now it's this third, or this mysterious second force, the barycenter force, which really is the perplexing thing, which is it's missed in a lot of analysis discussion about what causes tides. But it's very important. It allows you to have such a large high tide at the farthest point from the moon, that is, on the other side of the Earth. Force number 2 is kind of what you think, the sun. The sun is like, the figure escapes me, but it's something like 400 million times as massive as the Earth. So the Earth-Sun barycenter is right smack in the center of the sun. So there isn't much role with that. But you do have differential gravitation from the sun, from the side of the Earth that's closest to it, to the side that's farthest. So there is a little bit at play there. In fact, the sun's gravitational accounts about 42% of the degree of the tides, the value of the tides we see each month. And then there are local factors, but I'll just toss in briefly about this. Shoreline geography and the undersea terrain are a big deal. So if you have various terrains under the sea, it may cause the water to rise a little bit more than it would otherwise. It may, the shoreline geography may delay the tide by a few minutes, or accelerate it even by a few minutes, and make the value of those tides higher or lower than what normally would be. Now, there are there are 3 types of tides I'd like to discuss here. Something called the spring tide, the neap tide, and I'll get to the third one here. Spring tide is when the sun, Earth, and the moon all the sun and the moon act in unison on the Earth, causing an extra high tide. This happens twice a month because twice a month we have either a new moon or a full moon. And during those times, the tides are a little bit higher than what you would normally have. Now, the neap tide isn't really the opposite. It's just when the sun and the moon's gravitational forces are operating at right angles. So those high tides aren't nearly as high as you would in the spring tide, or the tides in between these two happenstances. Now, the other one I want to talk about, just gloss over here, really is called the king tide. And that is really a super spring tide. Oh, one more thing. The spring tide, the name spring, has nothing to do with the season. It's spring, as in spring upwards. So it's a little higher tide than what you would normally have. Well, the king tide is when you have a spring tide from the new moon, but when the moon is at perigee. So it's closer to the Earth than normal, a little bit greater gravitational pull than it has normally. So the tide is a little bit higher. And tides like this, a lot of localized flooding could occur but it only happens once in a while. So you may not catch it. You may not realize that it's even happening, but it can be of a concern. Now I have a tide chart. Okay. From Oceanside, California. This is back in April when I first started thinking about all this. I happened to be in Oceanside, and I was just showing some people how this varies. And I'd like to point it out here on what's going on. This is said back in April, Oceanside, California. Okay, we'll go to the high tides. That's the spring tide would be right here, and that happens to be in April. We had a perigee new moon, so this is really a king tide that's happening right here. It goes quite a bit higher than what it normally would, and as you can see, each day there are 2 high tides and 2 low tides almost each day, simply because since the moon rises 50 minutes later each day, once in a while, we just won't be able to squeeze in that extra high tide. But it's all in a cyclical value, and some get hot. Some you see the high tides are getting higher, then they're getting lower, and so on. This is pretty much how it looks. So when you're at the beach, you got to think about what you're seeing and how it's really affecting you. You see the tide go out, and you're thinking, "Gosh, what's going on here? Why are there 2 high tides? Why are there 2 low tides? Why are these tides of unequal height?" If you're at the beach for a number of days, you will see this thing change. This isn't the same. It's every day, as I said, 50 minutes later. So these tides vary, they change noticeably after a few days. So you look at all these factors there, and you can actually see this for yourself. This is one way that the celestial forces are at play and affect your stay at the beach, your enjoyment of the beach, because it may be all high tide, no beach today, no beach now. But come back in 2 hours, and there certainly will be. So this is something to take into account over the next few months when you and your friends head off to the beach and wonder what's going on with the water. Why is it way out there? Why is it high? So keep all that in mind. There really is an explanation for this, and hopefully I covered all the major points. Thank you, Terry. Thank you, everybody.
Sure. Thank you, John. Well, that's interesting. Now, the next time I go to the beach, I guess I'm going to be thinking about that now. Thank you.
There is one thing I would like to add to this. This amazing lecture about the tides. I have some personal experiences to share about the tides, because I was at a place on Earth where the highest tides take place, or the most dramatic tides, and that is in near Wolfville, Nova Scotia, where the Bay of Fundy empties into the Minas Basin twice a day. And when you're on the cliffs overlooking the Minas Channel, and at mid incoming tide, it's called a tidal rip, where the bay is really crashing into the Minas Basin, and the noise is almost deafening. And that noise is from the moon. So it's the day I heard the moon roar when the tides came in from the bay into the Minas Basin. But I know at one place near there, they recorded once a tidal difference between low and high of more than 50 feet. And it's really something to have this.
Yeah, that's incredible, because keep in mind that the time between its lowest tide and its highest tide is only 6 hours.
Yeah.
So this bay is filling up in 6 hours, and then it has to turn around and empty again
Yeah.
for the next 6 hours. And then next 6 hours after that, it fills up again, back and forth. So it's going on all the time. And something like that is really extreme. So you're definitely going to notice it.
All right. Well, thank you.
Oh, thank
that
you.
was really interesting.
Thank you.
All right. How about next up?
There's one
We
other
talked
thing
to.
I'd like to
Oh.
say, Terry. One other thing, and that is the tides aren't just on Earth. And in fact, one of the most important events in modern astronomy started because of a comet that broke apart near Jupiter in 1992. And that was because of Jupiter's tidal forces broke the comet into 23 pieces. And a couple of years later, the comet collided with Jupiter. Just wanted to add that as well. Sorry to interrupt you, Terry.
Oh, no, no worries. No worries. Well, thank you, David and John. Appreciate that. So how about now if we talk to Don Nab? Now, Don is the chair of the Mideast region, which we call Merrill. It's Mideast region of the Astronomical League. And he's going to talk about the night sky this month, I do believe.
That's correct. All right, let me share my screen. I'll keep it fairly brief, but I'd like to go into a few highlights of the night sky. Okay, we got June and early July. I wanted to extend into July a little bit because there's some fun stuff going on in July. I wanted to not skip. So every month, John Goss puts these together, and the Astronomical League puts these out. These are freely downloaded at the link you can see here. One about late in the month of June with Mercury and Catherine Pollux. On the right is the Seahorse asterism, one to look for. And the one I like most, the one I hand out to as many people as I can at star parties, at classes that our local club teaches, is the June night sky. This is available in English and Spanish. And actually, I just met with a very nice couple on Tuesday night. They asked me to help with their telescope, which they had no idea how to use. It was a nice gift from a family member, very well intentioned, but they needed help with it. So I had fun with them. And I gave them this, said, start here. Get a red flashlight, sit out under the stars, put the direction you're looking of this sheet at the bottom, and follow these directions. So again, big thanks to John Goss for these. I've handed out many of these monthly sheets, and they are available every month.
Actually, Don, thanks for saying that, because I don't really get a lot of feedback for that stuff, but it's nice to know that someone finds them useful.
Oh yeah, I hand them
you.
out as often as I can, and I email them to every club in the Mideast region every month. So and I get emails back. People appreciate them. So full moon, June 11th. Now I'm calling this the tree's fully leafed moon. It's also called the strawberry moon, but I like the names on the Royal Astronomical Society Canada calendar. I go by that one. And I missed the GSP on Tuesday. I've seen some of the recordings, but I know Kent Martz came on. He talked about the June full moon, the summer full moons being so low in the sky. And he's exactly right. And I love the way they light up trees. We're fortunate at our house. This is not our front yard. This is about a 150-year-old oak tree that I took at a local preserve, but I can imagine the moon hitting this from a very low angle and just lighting up like a spotlight. We see that from our front yard. We have trees across the street, and this low June moon is always something I look forward to, especially when the fireflies are flying around on our front yard. So this is the tree's fully leafed moon. That's my favorite name for this, but you can call it the strawberry moon. And right now we're eating all the strawberries we can stand. They're so good. New moon's the 25th. This is going to be a perfect time to be at Astrocon at Bryce Canyon. I'm really looking forward to this. So I will see many of you there. In early July, we have the lunar X and the lunar V around 7 o'clock on July 2nd. This is a clair obscura effect where light and shadow create an X and a V. Okay, and this is where the X is at, and I've blown it up over here. And then further up is the V, and that's over here. This is a lot of fun. We've actually organized star parties where we have club members come out and the public, and just to see the lunar X and the lunar V. It's only for a few hours because you have to be at just the right spot in the Earth's orbit around the sun and the moon and where you're spinning around the Earth. So it's got to be just right where you're at on the surface of the Earth. So, but it's worth making the extra effort to see it. The lunar X and lunar V are so much fun to see. They're my favorite two things to see on the moon. Although everything's good to see on the moon, as Robert Reeves would say. And then on the 3rd, one night after, we have the straight wall Rubus Recta to see on the moon. Another wonderful thing to show people at star parties. So the planets, unfortunately, our evening skies, other than Mars, we're not going to see much for the next few months. If you're up before dawn, Venus is nice to see, very bright. Rise about 2 hours before the sun. Mars is about the only planet we can see. I mean, we'll see Jupiter for a bit, but Mars it's falling behind us. We're winning the race around the sun. and it's going to be very close to Regulus around the middle of the month. So that'll be a nice view in the eyepiece. Jupiter is quite low. It is disappearing behind the sun. It'll come back up in the morning sky in July. Mercury is visible the last week and a half of June, and the last week and a half of June. You can see it then. Again, it's just low in the west, and that's what John Goss's graphic mentioned for the month. The way it is low in the west. So Saturn rises around 3 a.m. I'm not one of those people that gets up to see it, but I'll be rising 1 a.m. by end of the month, and yeah, maybe I'll see that at Bryce Canyon. We'll see. We'll see how it goes. So I picked just to focus on one object of the sky rather than cover too much. I want to keep this fairly brief. I'm looking at Ophiuchus and the surrounding region. This is a huge constellation, one of my favorites. I know when I see Ophiuchus, I know that Sagittarius and Scorpius are not far behind, and they are just filled with the riches of the southern sky for us people living at 40-degree north latitude. So I like to look at M10 and M12. These are two nice globular clusters near the middle of Ophiuchus. Then I'll talk for a moment about IC 4665. It's a very large, sparse open cluster up by the shoulder. And then these two over here, we'll spend a moment on those two, NGC 633 and IC 4756. So this is what perhaps M10 and M12 would look like in the eyepiece of an amateur telescope. Certainly there are far better pictures of this available. You can download on the internet, but this is a pretty good representation of what you will see in a typical, homeowners or amateur astronomers, not a huge 36-inch knob, but, a refractor or a medium-sized reflector. I took these with my C-Star, but this is about what it looks like in the eyepiece. IC 4665, this is a very bright cluster, but it was not included in the Messier catalog, probably because it's so loose and so coarse. But this is a fun cluster to see in binoculars and to show people at star parties. Then we always talk about the double cluster, the quote double cluster that is is beneath Cassiopeia most of the time, but this is what's often called the SO, or the Serpens Ophiuchus double cluster. And sometimes these are called the Tweedledee and the Tweedledum clusters. Okay, these present a very fine view of binoculars. So these were named Tweedledee and Tweedledum by astronomy author Stephen James O'Mara. 6633 is often called the Captain Hook cluster or the Wasp Waist cluster. I guess we can sort of see a thin spot in the middle here. Graph's cluster is IC 4756, or the Secret Garden cluster. I don't know where these names come from, but they are always entertaining, and I get these out of Stellarium. They're fun. Then I can't skip seeing mentioning the wild duck cluster. This is one of my favorite clusters in the sky. Burnham described it as an exceptionally fine galactic star cluster on the northern edge of the Scutum star cloud, and one of the outstanding objects for its type for telescopes of moderate aperture. Now, moderate aperture, this would look good in a 3-4 inch refractor, or the bigger reflector you can get, the better. But really, in 6-inch, 8-inch, it will look very fine. And according to Burnham's, Reverend William Derman of England first resolved it into a cluster of stars. But Admiral Smythe, he was a prominent astronomer of the time. He named a Messier 11. He named it the Wild Duck Cluster. I'm not sure how he saw this, but he said this object somewhat resembles a flight of wild ducks in shape. So I've always tried to see that, but I never quite get it. But it's a beautiful cluster, one of my favorites. On the left here is from my C-Star. This is what it might look like in an amateur telescope. And on the right is from the European Space Agency, ESO. This is the long exposure. It is just it's an open cluster that is so dense it almost appears like a globular cluster, but it is in fact an open cluster. So, and again, other places other than the Astronomical League that you can get maps is skymaps.com, or just search for What's Out Tonight. These are both very nice, completely free, refreshed every month, and you can download them as often as you want and hand them out to friends and family. We hand them out at star parties sometimes. So, and there's more than just one page. Skymaps.com on the left here has a back side which mentions all the like naked eye, binocular and astronomy, telescopic objects. And What's Out Tonight is actually a 4-page document and has the same things and other background about astronomy. So I would say get out there and enjoy the night sky. Back to you, Terry.
Well, thank you, Don. You are bringing big binoculars out to Bryce Canyon, right?
Oh, they'd be too heavy to carry. I'm sorry.
Well, that's true. You're yeah. Well, that's okay. I think it'll be dark enough. We'll be able to see some stuff pretty well.
I'll bring some small binoculars.
And
Yeah,
I'll try to bring some big ones. So,
there
Oh,
we go.
great,
Yeah,
great.
I'm sure you will. You'll probably, yeah. And you are going to loan those out, right?
of course I will.
Bring some of those
I
120s.
have a pair of 6-inch ED binoculars, but
Oh my
I just
gosh.
sold them today. So
150s.
Wow.
yeah.
That's massive. Bring some 120s. That'll be fun.
Okay.
Yeah, we'll take anything we can get.
Anything.
That sounds great. Well, thank you, Don. That gives us a lot to think about and a lot of different ideas for what we can view out at Bryce Canyon. So
Okay,
I will
welcome.
see you there.
Yes, I will. See you. Yep. Okay.
Okay. Thank you very much. All right. So what we're going to do now, we're going to get to our keynote speaker for the night. His name is Matthew Ryno. He is a published citizen science and president of Milwaukee Astronomical Society. He's going to speak on his journey in citizen science and how it helped increase interest in astronomy at his 93-year-old astronomy club.
Wow.
The early adoption of the Unistar V-scope has brought renewed interest in scientific research during a night at the observatory. Learn how members utilize a 4.5-inch telescope to monitor exoplanets, asteroid occultation, distant Trojan asteroids, and even NASA's DART mission. The talk will also focus on how his club constantly supports award-winning youth science in astronomy through outreach. We will learn about a variety of citizen science opportunities that allow you to participate from any location to study the night sky, promote dark skies, and to learn about astronomy with no telescope required. So welcome, Matt. Thank you very much for joining us.
And can I jump in for just 10 seconds? Because I'd
Sure.
like to say something about Matt. I've known him for 2 years, and this is one incredible person. He is a supreme mentor of the young members who come to the MAS. And that has reflected in the fact that over the last 4 years, we've awarded 16 Horkheimer Awards, which all carry cash prizes of $1,000 or more. And 9 of those 16 have come from the Milwaukee Astronomical Society, mostly because of the work he's done.
Well, and thank you for the support. It's a big boost to our youth entering the field. All right. Well, thank you for having me. I'm really happy to be able to kind of showcase a little bit what we're doing at the Milwaukee Astronomical Society. There is a little bit of a, when I took over and being president, you'll see in my talk, it was a little bit of kind of getting used to the vast history that came before me at the Milwaukee Astronomical Society. I mean, we say 93 years, it's been longer than that. And as you see, I mean, it was throughout the Great Depression in the backyard of the city doing stuff. So just a little bit on my background. You can find us if you want to learn more about Milwaukee Astronomical Society. We're part of the North Central region of the Astronomical League, which we're coming up next in 2027 will be our 80th year of founding North Central region of the Astronomical League. So again, rich history behind us. I do a lot of the outreach programming, a lot of just going out doing sidewalk astronomy, as well as just all the work that a club requires behind me. It's actually the weather in Milwaukee is somewhat like what you see behind me. So we're very thankful for that, because sometimes it looks like this in Milwaukee and you have to go and scrape that snow off. So we're really thankful to have our 400 plus strong members. It's been growing And I think that's a testament to some of the work that our volunteers have done here to really get interest and really get out in the community. Just some of our scopes that we have, A and B would be some of our older telescopes that we have, and all these buildings are hand built by volunteers and members throughout the years. So it really takes a village and an organization to keep this going. Every Saturday night we use telescopes, including this 100-year-old telescope that I have on the screen right here. Still going strong, and it uses it's all manually driven with setting circles that were mechanically made way back in the day when you make everything. If you want a telescope, you make it. Now we 3D print telescopes and we do homemade telescopes, but the same spirit is there. So let's go back a little bit though. 93 plus years. I guarantee you they did not dress like this every day. This was just for a special presentation here when we moved to our 3-acre observatory space out. But before it started with an ad in the Milwaukee Journal right around the Great Depression, which was, hey, come on out and join us. They were loading up the backyard of this small, like, in the city lot, and this was the kind of parties that they were having out there. So we just knew at the time that we had to go out and start expanding because there's so much interest here. And some of the people who took the call, and one particular citizen scientist was a founder of the Milwaukee Astronomical Society. And I really wanted to talk a little bit more about the founder. So when Ed Halbach, and many, you might not know anymore, but some people might recognize the name, but he was one of those founders. And he took this photo when they moved our observatory out to what you see behind me. This was a scope just being constructed. And the auroras were so bright during that time. But because he was a citizen scientist, he wasn't satisfied with just taking that photo. And he also grabbed all the sunspots and he documented as much as he could. So solar cycle 17, back in October 5th, 1937, we can now refer back to it on this kind of photo. And I think I really like this because it's just that curiosity that somebody has to take a photo, document it, get the sunspots, log as many as you can. That kind of permeated in everything that these types of members did. So if you look at some of the science back then, Ed Halbach is involved with Project Moonwatch later on, and they were credited for finding Sputnik 4 remnants that would come down and crash in the pavement of what is now Manitowoc. And honestly, this slide scares me, and because it has math in it. And me as more of an outreach person, that's not something I'm used to showing necessarily to the public, but it was just a matter of fact back then. You took your chalkboard and you studied, you did your calculations based on trajectories of where these objects might have been. So the thanks you get as a citizen scientist, it's not much. In this case, we got eventually NASA came, they took away all the pieces, and many years later, this little piece of I think it was it wasn't very large. We got that back as a cast that was made, a little plastic print that we have at our observatory. So, sometimes being a citizen scientist is for the it's not always rewarding. Good example, going out in the cold weather as part of Project Moonwatch, and this was what they used to do that. This is a good example of that facility that they had built to use these little telescopes and calculate. So this is taken right out of our history archives here at MAS. So, there's a lot here, but essentially he graduated from college. He's looking for a hobby, found the MAS. He was instrumental in the formation of the Astronomical League. first president. Engineering talent, I mean, it really making setting circles, making things that would last for a long time. That was kind of the spirit back then. And, just that innate curiosity. So eventually Ed became, received many awards are documented here. And the final honor there, 100,000 visual variable star estimates on your 100th birthday. Wow. And that's just the curiosity of a citizen scientist. And you see him on the left, top left, accepting that award. It just what an honor to be looking at, oh wow, I'm the president now of an organization with this kind of history. So another thing too, he did grazing lunar occultations. I could go on for a while, and I'm not going to go into too much detail, but one thing I wanted to point out is he actually designed telescopes that were identical. And he came up with a cable system that could connect, so that it could communicate. And basically, there's the type of observation that he made famous, which was a grazing occultation. And so shown here on the left is an example. In 1977, 9 observers who obtained the graze results, 108 data points. So I'll leave this, you can read my screen. I can see that. If you're interested in reading more, come to our site. We have a great history site maintained by our club historian, milwaukeeastro.org/history. There's a lot to read there. I really encourage you to come check it out. But one thing here to note, though, is identical alike telescopes. You have that variable reduced of somebody having a different type of telescope or something. I'll come back to that. So another thing that I really like is just the inspiration that a lot of members can take from another active member who takes time to, they might know that they're not going to see as much if they spend an hour, 2 hours working somebody through how to do what they're doing, but it pays off and they love doing it. And that's just really what we all try to strive to do is, take that extra time to help somebody else become really strong at something they have a passion into. So, all right. So what made it work? Math, but yeah, definitely math. Dedication, engineering, using that local network of similar telescopes, mentorship, and those times you can celebrate success. So now let's fast forward to science today. What are we doing at the Milwaukee Astronomical Society to kind of follow up on that and keep that spirit going? Well, I'm really happy that as a member of the board, we made a case to the board of directors to say, hey, I've been using these smart telescopes since 2020 in my backyard in Bortle 8 zone, Milwaukee. And I've been able to do science. And I really think that these would help attract people to that early, hard to get over the hump part of doing science with as an amateur. So lo and behold, made a good case, and we have 2 of these at the Milwaukee Astronomical Society, and they're a hit for open houses and whatnot. And I'm going to talk to you about the science portion, because we all know that smart telescopes, we were a little bit ahead of the game when we got one of ours. The Unistellar is one of the first smart telescopes to come out, and it's still a really strong offering with a 4.5-inch mirror. A lot of like the sea stars and stuff will be a lot smaller, so it gives you that more light collecting. But what no other smart telescope manufacturer is doing is assisting with that citizen science. And I really wanted to point that out because, I think as club members, you might be watching this, you're wondering how do you get involved or how do you support that? So, I think there's a success story here, and I'm really happy to be able to share that. I think that youth in the photo, Jericho, you'll be able to hear firsthand if you come to Bryce Canyon. about how he uses his telescope in his backyard to collect data on exoplanets. And you can see his light curve right here. You know, we're able to get people at the MAS really getting involved and participating and joining people from around the world through these smart telescopes. And a company really supports having researchers on site that are active and communicating to be able to make, you know, these kind of observations. So when you're going to Bryce Canyon, I think you'll enjoy the talk. You let me know how it is. Jericho gave a great talk at our open house. We had their first one of the year. People loved it. So I think you guys are going to enjoy it. So unistellar UV scopes is great. We found it to be a good outreach centerpiece. Galaxies in 2 minutes. I mean, you all are familiar with just how smart telescopes have been taking over and really coming in. Now we go to MAS on members nights and we could see, you know, 3 or 4 sea stars sitting on a pad, and some of them talk. And it's kind of funny because we walk by like, what? But in addition to our unistellar EV scopes. So after somebody uses one of our EV scopes, they upload that data overnight. It goes to the SETI servers. That's another thing that really attracted us to this company, because they were intricately linked to the SETI Institute as part of their founding. And then sometimes you might not even know it, but good things can come out of when you upload your data that way, or you could participate in a mission. So a few just technical details, because really it's about the people that I wanted to tell the story. I wanted to give you some cool, you know, just stats. So what we're using to collect this data, I mean, this is it. We're using 7.7 megapixels, 114 millimeter mirror, f4. So it's a little bit of technical stats right there, but we can get at a limiting magnitude of 18.2, which is really cool. So talking about that, upload that data. So when we first got one of our telescopes, we were in the process of collimating it. And we had a whole group. We made an event at the Milwaukee Astronomical Society. We had people come out. And then, yeah, it turns out, you know, we uploaded the data. We knew that there's a supernova happening. And we took a picture, which you can see kind of on the left and the right, before or after, right? And that was used by the SETI and unistellar scientists who kind of sucked the data that they were getting in of M101, of just people in their backyards taking photos, but then uploading at the end of the night. And they were actually able to produce a light curve of the, you know, rise and fall of that supernova, which I thought was pretty cool, because that was a lot of people just enjoying backyard photos. And in our case, we weren't even done collimating yet, and they grabbed, you know, some of our data. And we were able to contribute. So it was really easy to be a part of that without even knowing. And of course, persistent monitoring then, once we found that, all these little dots you're seeing are data points from people around the world, including us, who are sending in data and becoming part of kind of that target brightness measurement. So it's pretty interesting to be a part of. So what do we do with citizen scientists with a little 4.5-inch scope? Well, one of the things we do is near-Earth asteroid rotation modeling. So what we can do is track some of these near-Earth asteroids. You can see it being tracked on the left there. And we basically get a light curve from all the little bits of rotation that are in there. And it, you know, ultimately all this data comes in, and it can be used to help confirm that both the trajectory is still on track, as well as any of those, you know, surface, you know, oddities that might be there, including some just more detail to make a model of an asteroid. So that's one element. So, you know, we can also collect collective observations to make, you know, just a light curve of asteroid Ivar in this case. So that's another way of looking at that. it's helped confirm Trojan asteroids. So this was right around before Lucy was launched. They wanted more observations to, honestly be sure sometimes about the targets that it was going to go after. So a lot of us citizen scientists got to join in and picking some targets that were, on track and really confirming and getting more data in, because really amateur astronomers, we all have the benefit of time, whereas some of the larger telescopes, they can't be devoted to all the millions of things we want to observe. So amateur astronomers, we really benefit from being able to go out and keep coming back to some of these targets and confirming things. Asteroid occultation. So it's basically a brief point in time when an asteroid is expected to fly between a bright star and us. These are exciting. I've done these a few times at the club, and we all get really into it. Like, did we get it? Because they can go quick. The timing is very critical. And some of our members have caught these asteroid occultations. Other times we haven't. And sometimes that negative in science, that's still very valuable. So the fact that, with these telescopes, we can get the data in and a pipeline that comes back, and we can see and interact and chat on them. I mean, I think that's really special. It's just something I think about, how could you, if you were to onboard somebody in the citizen scientist, or to be a citizen scientist or to be an astronomer, how would you want to do that? Well, you probably want to get them interested with, actually seeing some data and presented in a graphic way and having that live interaction with researchers. This one I just did recently. It's pretty cool. So we can actually monitor different types of artificial satellites. So keep watching. There he goes. It was quick. But this is actually was out of control satellite Cosmos 2553, launched by Russia in 2022, right before its war on Ukraine. So there's a lot of, we don't know what's going on necessarily with that, but might be out of control. So by getting more and more data points through amateur astronomers like us, we're able to centralize that, upload, and it can confirm trajectory, because there's a lot of stuff going around the Earth. So these telescopes are very strong on doing that. Something that I was really proud of and I thought was really exciting is to become part of confirming the DART mission. So the DART is like the best name that NASA has come up with as an acronym for the Double Asteroid Redirection Test. And essentially they shot a satellite at a double asteroid system, and they wanted to see if they could have an impact. And some of the telescopes of the world were really unable to catch the whole thing in full. So I was very lucky to join in at the right time. I think it was like 3 a.m. my time, and I was like, yes, let's do it. It came out, got some data about before. Other people were on Reunion Island. They captured the actual impact. So our whole network as a whole, we all formed the eventual video of the impact, which you could see, and then the after and then the before data, days and days and days, months, weeks later. And eventually, the thing that I love about working with a telescope company that values that kind of interaction was that we could actually work with the researchers and post up in Slack when they're writing their article, which they eventually submitted to Nature. And you can see the cover right here. And yeah, lo and behold, a bunch of us citizen scientists, we have our name in Nature magazine. We were one of 5 studies published at the time to confirm that, yes, this redirection test did make a difference. A small difference, but it made a difference. In fact, it's still making a difference. I read not that long ago, but there's a classroom out in California that's they've been studying kind of how it's been breaking apart a little more. So it's just become part of the curriculum. They'll go out, take a telescope, and continue to monitor and get that data as much as they can. So very cool. It's nice to be a part of the network of observers from little cities to big cities, and be able to do that. So another cool thing we do. I mean, I think they're wonderful telescopes. It's also the people that having such an easy to use onboard citizen science telescope allows us as leaders of the astronomical societies to focus on working with the people using them too. So that's another thing that keep in mind. One of my favorite things to do is exoplanet monitoring, and there's a lot of exoplanets out there, and they're exponentially growing. I mean, I think if I were to have this talk maybe in the 90s, it would just be, I'd be in the news talking about it. And now we have 5,000 exoplanets. We're expected to see more and more. Our space telescopes are getting more and more powerful. They're able to see entire swatches of the sky for possible candidates. TESS has been a great builder. NASA will, highlight these candidates. They'll see the possibility for an exoplanet, and they benefit from having us citizen scientists keep tracking those exoplanets with our telescopes and confirming that things are as we expect. And yes, it is a target of interest. A lot of our exoplanets are very, very large. So of the ones that are found that we tend to look at with our 4.5-inch telescopes, they tend to be the biggest, gas giant type of exoplanets. But there's a lot out there, and hoping to have even more. So, one of our initiatives that I'm involved with is, we call it Unite, but it's a NASA partnered mission. So, a couple examples up here of going after TOI 1812 for three nights over the course of 2 months. A lot of times we'll get these missions come in, and you're just part of one observation because it worked in your part of the world, and then you won't see a result until a year later when people finally have time to look at the orbit again when we have another chance. So these are a lot of fun to do, and they really help nail down the exoplanet orbits and maybe find something interesting, because the more we look, we see. And what I'm showing here, I should explain a little background. Probably have gone on the deep end, I think. But what we're looking at, all those little dots are possible planets. And when they go in front of that sun, it lowers the brightness of the host star. And so what we look for is a pattern of that recurring, and how long is that dimming occurring. So if we put that to a graph, what we can do is we upload our observations, and then it can be extrapolated in this way that let's assume the red line in here is NASA's expected model for this exoplanet, and then our little dots from our telescope, in particular our little 4.5-inch telescope, you see in gray they can be all up and down, so we take a weighted average of the many readings, and then we plot them with the model fit. So that's how we can do that with a very small 4.5-inch telescope. It's pretty neat just how technology has evolved. And wow, just look at how far away this stuff is, 935 light years away. And what I like to note too is the discovery date, 2022. And it's very exciting, I think, for members to be able to track this kind of data with the telescope at your observatory. So, we've come a long way. There's just some more, larger graph, for example, of kind of some of those results that we can grab from these telescopes. Another one. Now, if we want to get fancy, and we do sometimes, what we'll do is we'll take, over the course of many days, we'll collect data from all over the world, and we'll smash them together in one large cumulative, transit graph, what you see here. So this is one of those examples of taking a lot of observations from different people and bringing it together into a graph. So here we are looking at a super large exoplanet. and we needed a lot of time. Sometimes we get eclipse in binaries, which is also really cool. We're seeing stars go around stars. So you think of Star Wars, looking up in the sky, tattooing. But anyway, that's part of it, as you investigate an object of interest, and it might turn out to be something that is something else. So anyway, what do we do to make this exciting for members? One of the things we do is we make sure that we celebrate success. So like at our observatory, yeah, we have pictures and astrophotography. In fact, we just had a massive gallery with like 70 photos at a local community nature center, which is really cool. But I also tacked up some exoplanet work on that wall too, anywhere I could. And we have an entire wall at the observatory behind me devoted to science missions that some of our youth exoplanet hunters have found, other members have found, anything. We'll put it up there and really celebrate it in our newsletter, whatnot. Another thing that really works in today's world, and which I really appreciate, that Unistellar supports, is their researchers are literally in the Slack groups communicating at all hours with observers and amateurs. And it allows, is your student getting into observing, it allows you that connection with the researcher and the possibility to influence, or at least have a conversation with other observers when you're sending that data in. So we have a routine when we send our data. We kind of note in our relevant Slack channel, like uploading overnight, look for the data, and then we'll get the confirmation either in results, or occasionally there might be an intern or a researcher who might have to take a deeper look at some of the results or questions that are coming in. So that's really cool. The other thing that I think has just been phenomenal to see and to really take advantage of at an astronomical society like ours is the fact that they're putting out predictions like this that are very intuitive, easy to spot, and then you can add them all to your Google Calendar, and it really helps to kind of schedule around if you want to meet like another member out at the club at a certain time, or if you want to work in your backyard that elsewhere, but you're both going after the same target. It's really a powerful tool to planning your night. I don't see anyone else really doing that in the smart space or smart scope space. And then, wow, you even have a portal. You can log in and download your data. So I wanted to kind of showcase what that would look like. Just went in, and you can pull up, the charts that were generated by, the Python script that runs to give you these nice visuals. Or you could just download the raw data and manipulate it yourself if you want to give it a shot in running your own model fit in maybe Astro Image J or something. So it can scale with your talent. So this is an example of just if I wanted to pull out some of the nicely formatted data that comes out of the telescope, that comes out of Unistellar's visualization scripts that they run. I wanted to share TCRB data. Obviously, you can see on the top, the light curve has been pretty consistent. Unfortunately, it's been one that we all spend time going out and getting observations on, but hey, maybe one day it'll go. But it's just pretty neat to, you get that receipt of your observation, you can work on it. And, I mentioned the DART impact. How cool is that to have your name associated as a data collector, and, a small portion of that research team that comes up with the final paper. Think about it in terms of if you're going off to college or, trying to pick something, and imagine presenting this as one of your pieces of evidence to come get into the, astrophysics department. So it's a wonderful tool, and I'm just very appreciative of the support and way that they embrace students kind of learning. Coming up, I'll give you a little teaser. If you get your edition of Sky and Telescope, take a look. There's a really good piece coming up about outreach and what's going on in Boise with their astronomy department using these telescopes that I'm talking about. So I'm not going to play the video, but Unistellar posted a good interview with some of the students who are in that educational department. But they're finding a lot of success with having these as part of their curriculum. So I think in review, if I go back, I wanted, this is really about the similarities, I think, between citizen scientists back then and now, is that, curiosity coming out, that mentorship that, is embraced. And it's really, some of this is the same of what we would be doing, except now we have technology to assist us. But I think what has helped with our youth is that publishing the results. It's helped with our adults, obviously, too. By seeing that our 4.5-inch telescope for outreach is incredible. We can see galaxies and nebulas in Bortle 6 zone, where observatory is now, as light pollution keeps encroaching on us. And it even has an eyepiece. So for outreach, these are wonderful. But for citizen scientists, I hope that you've come out of this with a takeaway that there's a lot more that you can get through this kind of telescope. And then, I think I wanted to look at too, what is making this happen as far as if you're at a club and you're watching this presentation, you're thinking, well, we already have some stuff that we use and we track exoplanets already, or we do this already, or we do astrophotography already. I think just this whole experience of seeing how the Unistellar's app has been designed just with this user experience in mind, ease of use, I think we can take a lot of takeaways out of this. One is, if you can, try to offer a smart telescope at your astronomical society. There might be a vendor who's willing to lend one out to get hands-on for people, so never hurts to reach out. I think us as in astronomical societies, we have people who are influencers. Lots of times they get all the credit right on YouTube, and they get all these free products. But think of your astronomical society as that place where people really can be hands-on with the vendor equipment, and make that case to the vendor directly, or a grant. I've seen these Unistellar telescopes supported at people's observatories through grants and outreach. Whatever it is, I think embrace it. It is something new coming in. Smart telescopes are, you're going to see more and more. Gosh, I have this nightmare that one day I'll open the closet and there'll be like 50 sea stars that fall out. Hopefully it doesn't get to that, but if that does happen, we might be able to connect them all together and do some really cool stuff for citizen science. So embrace it. I think what I see sometimes is there's a tendency to compare apples to oranges, and some people might say, oh, I can see this in a large visual telescope. Why would I want some other smaller small sensor thing? I say resist that temptation, and if you see that, maybe try to encourage adoption of just enjoy it together. And there's so much we can see that might be different in an optical telescope and a visual telescope. Same thing too with technology. I think so much we get wrapped up in how many megapixels does something have, or what sensor is it? Ultimately at the end of the day, you can do the work with a variety of sensors or cameras. So I think that's helped a lot, is having being able to work with kind of your key holders, your members, your people at your club that have an open approach and a mind. And I think we've seen the payoff when people are excited to bring their smart telescope, join in with other observers, and you get a variety of experiences. Anyway, so even if you are doing citizen sciences or science, consider your assumptions too. you know, lots of times we get wrapped up in our systems, and then when we think about explaining it, it's not simple. So if whenever possible, try to you know, read your process on an outsider, read it to them, get some of their input. At the end of the day, you don't need a degree to run the you know, equipment, so try to treat it as that sometimes. I'd say also consider training and teaching on open source tools. So a good example is if you are so used to processing astrophotography on PixInsight, you know, but you're going to be talking a lot about processing, learn Deep Sky Stacker and learn some of those free open source alternatives, because you're going to get questions on it, and sometimes that's the way to bring people into what you're doing. You know, GIMP over Photoshop, Nina over SGP. Have that background knowledge, and then think about, you know, people who come in and they have a Mac and they've never used Windows. What can Cyril do that, you know, maybe you do with PixInsight? It's worth that investigation for all of us to kind of spread that knowledge and embrace it. Other ideas, offer manuals on the observatory grounds, record your video. Even if you don't write a manual, just now you can have just AI grab your recorded video and turn it into a website that you tie a QR code to on, you know, for your station, and there you go. So all those things are really important, and I think you know, I wanted to go beyond a little bit of the global, you know, network of citizen science. It's just what can we do day to day to improve. Myself, I'm an outreach person. I say I am communications is my major, right? So don't overwhelm with math and numbers, gross. But when you're showcasing results, think about, you know, what does this mean to the public? And then very important too is if you can get a training schedule posted or a calendar so that your members know great times to come and not feel like they're bothering anyone or disrupting you, but they know that they can come, follow along, shadow. And all these are great, I think, in terms of, you know, getting people to the observatory to learn your piece of equipment, and then on top of that, having a piece of equipment that makes it super easy to onboard into it. These are all great components, and so I really wanted to showcase that. I could keep going, so cut me off, but I wanted to think about too, what if you don't have a telescope and you're watching this and you're really curious? So you can think of Clyde, and he wanted to find Pluto, and he used the blink comparator. So he had that dedication to go in and constantly grab data and then compare it and compare it. And he did this himself. He's able to find something's different in this picture. And it might be something that's moving. It might be a planet. So if you could spot it, there's something that was moving, and it was a planet. And so that's that model that citizen scientists use. And you can do this too in your computer screen, and you don't need to have a telescope. So there are a couple projects out there where you could look for brown dwarfs. So this is an example of, you'll get a piece of data like this that comes in. So you can do this while you're like working out on an exercise bike, maybe, or just maybe you want to set this up on your 40-inch TV and you want to really spot it. Anyway, you'll go to the site and it'll ask you, do you see something moving? And then you'll go through maybe 10 of these. You'll get 10 of these data points. And what you're doing is you're helping cut through noise using your human eyes to notice differences in patterns. And believe it or not, AI can't do some of this. It gets confused, or AI is doing so well that it's grabbing so many results that aren't really things that need to be looked at. So you could be a citizen scientist at home, just going through different screens and confirming what you see. So there's many more things out there like that. I wanted to give you a taste of it. You can go to science.nasa.gov and just do /citizen science, and they've got a ton of resources out there. It's a wonderful site and location. Another, you could also go to nasa.gov/solve. That's another great site. Also, Zooniverse is really doing well. It's kind of a hub for citizen science. If you haven't gone there, give it a look, browse it. You can create an account, and then it will keep track of all your contributions through that account. So just that user interface, it almost gamifies the act of going in and constantly grabbing data. That's really cool. And then, of course, if you're into amateur astronomy or just citizen sciences, anything, here's just some apps that we use. Give a few a try. And then, of course, I have their site on there. But one of my favorite ones, and if you're in a club and you haven't signed up for Astrospheric, make sure to create a page with Astrospheric and allow your club members to join, because you get access to more features through that app. We use this at the Milwaukee Astronomical Society. I love it because I can plan with my family. Like, I'm going to be gone for a long time at night, and we have 3 days notice to plan for that. So that's probably the most important app for getting involved. And then, as we saw that Chuck showed, you could be a dark sky protector, really an advocate. There's a program in the Astronomical League. I mean, I think light pollution is increasing globally at a rate of about 2% per year. Observatories like ours, who have 100-year-old telescopes, those can't move very well, and they're getting encroached on by light pollution. You can see that we've evolved and we're using different technologies. And geez, I'd love to in the future have a electronic eyepiece and that we can stick on that 100-year-old telescope to really give a boon to it. But this is the problem, and some of it's preventable. So just keep in mind lights, like the right amount of light needed at the right time. Turn it off if you're at a workplace that's contemplating projects. Get involved with your workplace. Talk about fully shielded fixtures. All these kind of resources, because really it's taking away from our dark skies. So if you want to do a citizen science twist on this and you don't have a telescope, you could go to Globe at Night. One of my favorite apps is Lost of the Night. It's an Android app. You literally could take, and I think it's an iPhone app too. You could take your phone, lift it up, and it will guide you through like 5 prompts. It will tell you where to point your phone even. So then when you finally get close to the object, it'll turn kind of orange like this on the left. And then it just asks you, you're here, can you see a star? And you say yes or no. And you do this maybe 4 times, 5 times. At the end of the session, that's it. It says thank you, and it uploads, it creates a number score, and then that gets uploaded to be used for calculation of dark skies. So you don't have to have any equipment. You can just use a cell phone to do that. It's pretty cool. Lastly, the folks over at Unistellar just wanted me to mention, if you are interested in they're offering to give a free backpack if anyone purchases one. So I have those promo codes on top if you're interested. So grab your screenshot now. All right, I'll move on. All right. So with that said, I think that's the end of it. So thank you for the opportunity to talk, and I'm really looking forward to Jericho's talk at Bryce Canyon when he talks about the service award and just what he does with citizen science.
Well, thank you, Matt. I think it's amazing what you can do with a 4.5-inch telescope. I mean, when you look at the type of work you guys are doing, that can be done with citizen science. That's incredible.
Indeed.
You are in so many different areas, and it's just, I've never really considered something so small that could do the type of work that you guys are doing.
It's incredible too when you have you're in the middle of the city and especially over 4th of July, you know, you have people launching fireworks everywhere, and you're still in the back. You're able to gather data on an exoplanet and send it in.
Yeah, that is amazing. Wow. How many kids would you say there are, or youth in your club? Are there quite a few that are really interested in some
Yeah,
type of citizen science?
you kind of have your core group. So, and we
Yeah.
found, you know, kind of train the trainer. So once you have a really successful youth, they have friends, they bring them, you know, look what I'm doing, and then, you know, you have more members. So I think it's just important to keep doing the outreach to, if you can, to schools of different ages, middle schools, high schools. A lot of clubs at high schools don't necessarily have that support, so that's where we find two, um, you know, astronomical societies can offer that support, where maybe there's, you know, a teacher who's trying to do 100 other things and they get asked to run a club, or if they're
Right.
lucky enough to even have that.
Yeah.
So, you know, coming to the observatory is an important part of that. I mean, I think once you have an amount, you got to understand that they're probably going to go off into fields and college and be successful. So
Sure.
it's just continuing to reach out as a club and, you know, find more that would be interested. And, you know, it just helps to have tools like this that
Yeah, definitely.
generate that interest. Yeah. And support. Many nights of going out to help with the equipment that is gigantic, and something weird's happening, right? Just the
Right.
willingness of
Yeah.
having a network of members to help with that.
Yeah. The variety. I think the variety, you could reach so many different people with different interests, you know, and especially to have all the citizen science programs like that. So that is amazing. Thank you so much. I know others have probably got comments or questions.
Yeah,
So
I have something I'd like to say. Thank you, Matthew, for sharing your astronomical life with us this last hour. I particularly enjoyed the picture you showed of T. Coronae Borealis because it reminded me of what Leslie C. Pelcher wrote about it in Starlight Nights. It was an absolute failure for him, but in writing about it, he turned that failure into the funniest part of his book. He got up in February the 9th, 1946, saw a beautiful clear sky, but he was very tired and not feeling well, so he went back to sleep. And then he wrote, "And thus I missed the night of nights on the life of T. Coronae." And his ending, which really got me to howling with laughter, was, "I still observe T. Coronae Borealis every night, but it is with a wary eye. There is no warmth between us anymore." Here is a man who sees the stars as personal friends, as you do and as I do. Thank you so much.
Thank you. One of the, I mean, talking with somebody of you, one of the comets that we've been looking at is 103P, Hartley 2, which is showing, you know, decreasing activity. It's just been amazing to be able to go after such a distant comet with these telescopes.
yeah, that's amazing. So thank you, Matt. That I really enjoyed your talk.
Thank you.
Yeah, I gave a talk up there in October of 2023, and I'd never seen an EV scope in use before. And they had it set up on that little pad you see right over Matt's left shoulder there. Yeah. And it was really not a good night. I mean, it was about 40% cloud cover, substantial light pollution from Milwaukee and Waukesha and Chicago, of course. And he said, "What do you want to see?" And so I picked something I knew would be almost impossible under those conditions, which would be Matthew 1 in Cassiopeia. It's a heavily obscure galaxy that wasn't discovered until 1960.
Wow.
And so he said, "Sure." And so I'm looking at this tablet and I'm very skeptical. And I said, "Well, it's going to be in a little trapezium of stars if it's visible at all." And it slewed and the screen was kind of gray, and I saw a couple of bright stars, and I'm thinking, yeah, this is not going to work. And then about a minute later, the screen popped beautiful black, covered with stars, the trapezium, and a big smudge right in the middle of it from the galaxy. I was stunned by its performance. So yeah, this is definitely something people need to embrace.
We're happy to have you out there. You gave a great talk. We'd love to have
Thank
you
you.
again sometime.
And congratulations on becoming president too.
Thank you.
You'll pay for that.
I think that was experience talking.
Yeah.
All right. Oh, does anybody else have anything?
Just some comments here. Yeah, Andrew Corkill is saying that citizen science is fun and highly recommends doing it. Dan Garrett from Facebook says, thank you, Matthew. Lionel Hernandez Chavez, greetings from Central America and congrats to Matt for his amazing work with MAS. It's nice to see a young citizen scientist. So there you go. Some nice comments.
It's nice to. She's talking about me being young, right? I hope. No, I'm just kidding.
All
Okay.
right.
All right.
Well,
Take us
thank
out.
you. If I can, I would like to share my screen. If oh, there, I'm already on there. What I would like to do is show we will be back next month. And next month we will, whoops. Well, we had it. Let me see what happened here. Try this again. Next
Oops.
month, there we are. We're going to have Vincent LaVita from Fairbanks, Alaska. He will be talking about cross it off your list, seeing the aurora off your bucket list, seeing aurora off your bucket list. Being in Alaska, he has got some amazing images, and I have heard him also speak before, and you will really enjoy this, especially since we've been able to see some aurora down as far south as what we are. So we've been really lucky. So please join us on July 11th at 7 p.m. EDT right here and watch Vincent's talk. And also hope we see everybody out at Bryce Canyon. We are going to have a good time. We have requested clear skies every night, and I think they'll listen. So, beyond that, let me see. Scott, well, I would like to thank everybody. Matt, thank you for giving us some of your time on a Friday night and an excellent talk. That was amazing. And thank you, Chuck, Don, David, John, everybody for being on and making the show so interesting. And thank all of you for watching. We really appreciate it. We wouldn't be here if you weren't here. So thank you, everybody. And Scott, I'm going to turn it back over to you. And Scott, thank you too for broadcasting.
Thank you. Thank you very much. It's always a pleasure. Okay. So let's end our spotlighting here. Here we go. And I will take us out. I do want to thank everyone for tuning in. As I mentioned, it's a pleasure and an honor to broadcast these programs for the Astronomical League. And we're all looking forward to Bryce Canyon and celebrating the night skies under those incredibly dark conditions. So, and until next time, we will see you and keep looking up. Thank you.
All right. Right. A little over 2 weeks. See you folks, huh?
Yep.
A little over 2 weeks. We'll be Bryce Canyon.
Good luck, everyone.